Okay, I'd like to welcome everybody to the afternoon plenary session for the CalFlexHub Symposium. It is my great pleasure to introduce our next speaker, Ram Narayanamurthy. Ram is an expert in load flexibility technologies himself, having done a lot of work with the Electric Power Research Institute here in California and EPIC, and he was just saying that things that he was doing in California, now he's doing with DOE. He's the Deputy Director of the Building Technologies Program at DOE, and he's a regional, a national, and international thought leader. So he's also doing international work. I'll let Ram, you can tell anything more about your background. The bios are in your program, the full bios. Looking forward to your comments, Ram, and thanks everybody for joining the afternoon session.
Thank you, Marianne. And you use the word expert, so that's always like a very loaded term. Again, I'm really happy to be back here. I was just telling somebody, a lot of the people I've worked with over many, many years are all here. We're all old friends, and we have had some great discussions over time. So it's a pleasure for me to, and a privilege to talk about what we are doing at DOE in terms of grid integration and demand flexibility. And it's, as I mentioned, right, it's some of it is actually comes from lessons learned working in California. Is there a clicker to move? Next. Okay, next slide, please. So I don't know how many of you have seen this. We released our National Buildings Blueprint to achieve decarbonization of the building stock by 2050. We did that about, I think it was in April that it was released. So as part of this, we are focused on 4 pillars trying to get to the end goal of economy-wide decarbonization. A lot of it reflects what's going on in the state. One is, of course, we don't want to forget building efficiency. I know when people run numbers and they run the analysis and you assume that, hey, the whole grid is decarbonized, efficiency doesn't matter. No, it's not true. Efficiency matters, and it matters even more as we look at affordability, as we look at resilience, but it's a core to achieving our goals for decarbonization. So our goal is to have all our buildings be 50% more efficient by 2050. We want to accelerate on-site emissions reductions with the goal of reducing it by 75% by 2050. It is a very, very tall target. There's technologies, there's installation issues, there's existing building stock and how we retrofit it. We want to transform the grid edge. I'll talk a lot more about it. And also minimize embodied life cycle emissions. So looking at, hey, where do the emissions come from, especially for new construction? Next slide, please. So when we think about what our priorities are going forward, we are setting the building's blueprint as the North Star for the Building Technologies Office, for the work we do, for the research investments we make. And so all our priorities are aligned to the building's blueprint. There's a whole bunch of different items here, but it talks about what we are doing in each of the areas around emissions reductions, doubling energy efficiency, grid integration, and working on embodied emissions and equity. I don't want to forget the fact that we have to make this transformation in an equitable manner. And for that, what it means is that we are looking at it as a concept of trickle up versus trickle down. Technically, technologies, or traditionally technologies, have always gone to they've started from the highest income brackets and made their way to the rest of the population. We want to focus on technology innovation, such as really small form factor heat pump water heaters that can go into multifamily housing and manufactured housing. We want to look at how do you electrify with a 100 amp panel, right? Those are the types of technologies we are looking at so that we can actually implement this philosophy of a trickle up of our technologies. Next slide. So when we think about our priority R&D areas, accelerating grid edge innovation is, of course, one of our top priorities. We realize that the grid is actually in the pathway of us achieving our goals, whether it's around the distribution system, whether it's around demand flexibility. How do we get there? Commercial HVAC systems are a big focus area. It was interesting. I was talking to people, manufacturers. We launched a new commercial rooftop accelerator to be able to get more rooftop heat pumps. I was talking to manufacturers and they said, yeah, hey, we sell about 8% of our sales are around rooftops, rooftop heat pumps. I said, that sounds really low because we all think about heat pumps overtaking gas furnaces, but it's on the residential sector. And then I went and dug up some old data, and I found a report from 1989 that said 8% of rooftops are heat pumps. So in 35 years, we really haven't moved along in the commercial sector with heat pumps. And I think accelerating that area is really going to help California meet their goals for the 6 million heat pumps in the next 6 years that Andrew is trying to hit. Enabling ultra-low GWP refrigerants. How do we get to the point of having refrigerants that are less than 10 GWP in our heating and cooling systems that really, once you go beyond electrification, the next remaining scope 1 emissions in buildings is from refrigerants. So how do we focus on that? Building envelope retrofits, and Sven will talk a lot more about it. Some amazing work that's going on in that area. Equity-focused R&D, I touched on that a little bit. Leveraging end-user partnerships. One of our big showcase partnerships is the Better Buildings area. Traditionally, we have been working with Better Buildings partners to do lessons learned and share lessons learned, but going forward, we are looking at how we can work with them as partners in accelerating technology adoption, whether it's for HVAC, whether it's for electrical infrastructure. How do we work with these partners, whether it's hospital, like just last Saturday, I was at a hospital in Fresno where they were breaking ground on a really large microgrid with long duration storage that will satisfy 80% of their energy needs. So working with those partners and doing field validations is a big focus for us. And the last one is advancement of building performance standards. It's going to be a challenge to address our existing buildings. Building performance standards is a priority for us. Next slide. So now let me dive into what we mean by accelerating grid edge innovation. Next slide, please. So what is a grid edge? It's a very nebulous concept. And what we've been working on is recognizing that transforming the grid edge is going to be critical to achieving the goals of electrification and demand flexibility. So we are defining the grid edge as a place where buildings, industry, transportation, renewables come together. And it's defined as being from the feeder to the plug. And so it encompasses equipment systems on both sides of the customer meter. And why is it important? If you're working on customer technologies like 120-volt heat pumps or smart panels, that automatically reduces the amount of infrastructure that you have to put on the electrical side. One example, for example, if you're looking, we were talking to home builders last week. One of their pain points is that they cannot get enough transformers. When you go to all electric construction, they are concerned that they're going to need more transformers. Where they used to put in 1, they now need 3, and they have a supply challenge. So if you can figure out how you don't increase the panel size of the building, then automatically that means that you are putting fewer transformers, which means that fewer upgrades on your feeders, fewer upgrades in the substation, reduces costs overall, right? So for us, that's a big focus area. We're looking at technologies on both sides. And what it does is it brings together all the technologies: efficiency, local generation, EVs, building decarbonization, IoT. Energy efficiency especially has a huge value to the distribution grid, because when you do an envelope upgrade and reduce the size of your heat pump, that automatically means that that measure stays in place for a long period of time. Distribution planners require long duration assurance of the load from that circuit, and efficiency can provide that. So that's why it's a integration of all these different elements, and that's a focus for us. Next slide, please. So one of the efforts we have started, it's called Supercharge. And what it is it is a collaborative effort between multiple offices at DOE. We are working with solar, with vehicles, with fuel cells, with geothermal, all the offices working together to understand how do we accelerate the move to a modern grid edge. A modern grid edge where your distribution planning is based on stochastic loads, because as we move towards better buildings, as we move towards more flexible loads, it is not about what that load can do at peak, but what do all of these put together do in total. So how do we adapt our distribution planning practices so that we are not upgrading distribution circuits? How do we look at existing distribution circuits, which vary everywhere? California is a great test case because California's distribution circuits are really strained in terms of their capability to handle new loads. EVs or building electrification. Places like Southern Company and Duke over in the Southeast, they put 3 homes on a transformer. We put 10 homes on the same transformer. So there's a huge issue around how do we actually decarbonize and get our grid to modernize. And we want to work with industry policymakers, regulators, technology developers as part of this journey towards modernizing the grid edge. Next slide, please. So what are the focus areas for us in terms of grid innovation? One is grid edge management. So I just mentioned that. How are we going to do that? It's about technologies, it's about DER integration, but it's also working hand in hand with the utilities around distribution planning strategies. How do we do better? We are looking at distribution system optimization. So how do you use your existing infrastructure to be able to achieve the goals that we have around building transformation? For example, in Seattle, we have a project, one of our connected communities projects in Seattle. And Seattle, the electric rate is 4.5 cents a kilowatt hour for low-income customers. And what that leads to is that most of the heating in Seattle is actually electric resistance heating. It's not heat pumps, it's electric resistance heating. So what we're doing is, okay, hey, if we can turn the electric resistance to heat pumps, you free up a lot of capacity on the grid, on that part of the distribution circuit, so that you can now add EVs and more demand flexibility to that part of the circuit. So it's looking at that interplay and optimization of the system between efficiency and demand flexibility. Gas electric transitions and thermal energy networks, that's a big focus for us too. We realize that as we look at this, it is not a cutover, it's a transition. PG&E has a great effort around strategic electrification projects, looking at areas where the gas network needs upgrades and trying to figure out if electrifying the entire circuit makes sense versus an upgrade on the gas network in that area. So we are trying to work with utilities like PG&E and National Grid and Eversource. Eversource is looking at network geothermal as an opportunity to go from a gas distribution to a heat distribution. So looking at those types of opportunities for the gas electric transition, and then the thermal energy network combining different heat sources, CHP, fuel cells, geothermal, air source heat pumps. How do you put that together? And then we're also doing a lot of work around policy analysis and training, including our rates. And I'll stop and maybe talk a couple of minutes about rates. So we have a huge challenge with rates. I am a non-solar PG&E customer, so I feel the pain every day of the rate, right? What we know is that there's a correlation between your variable component of the rate and heat pump adoption. So if you look at where you have high heat pump adoption, it's where it makes sense for people from an economics perspective. And that economics is driven by a low variable rate. So the Southeast, Northwest areas that have low variable rates have high heat pump adoption. Correlation is not causation, but there's definitely correlation in that adoption. So the question is, what is the type of rate structure that we have to move to? If you look at the utility costs, a lot of the cost is actually in the wires and the poles, et cetera. But we also have a lot of imbalances. So looking at different rate designs that can help us accelerate electrification is one of the areas we're looking at. How do we minimize the additional infrastructure that we have to put in place? Upgrading an existing grid is extremely expensive, much more expensive than when you're doing greenfield build out of a grid. That's because you have homes, you have roads, you have everything in place. How do we reduce the amount of costs that we put into infrastructure so that we can keep rates down while still looking at different rate structures that can help building electrification? And then also looking at how does policy get factored into rates so that you can achieve the goals of both electrification and flexibility together. So that's some of the work that we are doing with LBL and UC Berkeley right now. And that's a very important one because if we don't get it right, then there's a huge equity impact. The people who would feel the impact of it, a lot of the low-income customers would feel the impact of it because if you electrify with very high rates, it is going to hit people's pockets. So we have to be very conscious of that. Next slide, please. So as we look through this, this is kind of a problem statement on where we are going. So we recognize that Utilities are now facing a challenge that they haven't seen in decades, significant load growth. And that load growth is coming from multiple areas. It's coming from AI data centers that I think a lot of people have heard about it. We don't know how much of it is going to happen, how much might not happen. But it's also coming from, as we try to get more EVs on the road, as we try to get more electric trucks on the road, there's impacts on what that load growth is going to be. And so that's a challenge. 5 years ago, the challenge was around DER integration. The challenge was around, hey, how do we get more renewables on the grid? Now the challenge seems to be, how do we meet all this growth in load or the projected load growth while still being able to maintain and achieve our goals around a low carbon grid? So we are looking at all kinds of technologies, many different solutions. How do we address, manage, how do we do things like managed EV charging, low power appliances, smart panels? For us, demand flexibility is not just a grid grid interactivity thing. Demand flexibility can happen at the building level, where you are balancing between your EV and your battery and your heat pump and your induction stove, and managing all those together so that you can minimize your demand. So we are moving into an era where I think it's more about power efficiency. Not that energy efficiency is not important, but power efficiency is going to be very important. Next slide, please. And so part of what we are doing in this effort, it's what we call an EERE-wide effort. EERE is Energy Efficiency Renewable Energies. And it means that we are working together with multiple offices, with the solar office, with the vehicles office, with the office of electricity, with the geothermal office, with the industrial office. We are all working together to understand how we can get field data, how can we validate various grid edge technologies. This is part of what we call the Connected Communities effort. And how do we work with all the different players, HVAC manufacturers, OEMs, the smart charge management service providers, the utilities, the grid planners? How do we get all these different stakeholders to come together and talk together so that we can figure out what is the optimized right size grid for the future? Last slide, please, next one. And so for us, these are 4 targeted areas for RD&D. Field validation of what we call grid edge technical measures, anything from circuit splitters to demand flexible thermostats to building energy management systems. Field validation of smart charge management, that's a pretty important area as we get more EV adoption. And how do we do all this while maintaining customer resiliency? Resiliency is very important. As we go from 3 fuels to 1, that means that your dependence on one fuel becomes more and more critical. So how do we actually manage that resiliency through different things, whether it's providing backup power through microgrids or through better energy efficient envelopes? And then finally, we want to collect data. So if anybody's out here getting data on the distribution grid, we would love to work with you to see how we can get more data and understand what the grid actually needs. So with that, I will close. And I think I'm 1 minute over, but thank you.
Thanks so much, Ram. It's now my pleasure to introduce Sven Mume. He's a program manager, technology manager at the U.S. Department of Energy in the Building Technologies Office as well. And he leads a program called Store for Build, or Storage for Buildings. And he'll be sharing with you some of the work that he's doing in that portfolio. Thanks, Ben.
Yeah, thanks for the introduction. And Ram set it up my presentation really well. So I'll be talking about this new consortium, relatively new consortium, focused on thermal energy storage. I'll have some initial framing slides before I go into the consortium. So next slide. Also, just wanted to mention that I manage the thermal energy storage R&D portfolio as well as building envelopes, and building envelopes is critical, important to reducing loads. It doesn't just reduce loads one for one, but based on the delta T's of the day, exactly when demand is the highest. Typically, when temperatures are the highest or the lowest, that's where it reduces it significantly. So it actually shapes the load passively. So everyone knows about the duck curve. We need to manage it. The only thing I'll add to here is that it's not just a California issue anymore. More and more states, as renewable penetration increases, are seeing something similar. In some cases, actually pretty severe. Some cases, the beginning phases of the duck curve. Next slide. And as Ra mentioned, demand is going to increase significantly from today's levels as widespread electrification goals are we're progressing on those goals, and as those are reached. And I'll just mention that buildings is a thermal loads is a peak driver of peak demand. 80% of current peak demand is in buildings. Yes, you'll have additional peak demand based on a whole slew of additional different factors such as EV penetration. But still thermal loads are significantly driving that peak demand growth as we electrify space heating, water heating, appliances, and the like. So next slide. So we need energy storage. There are two forms, main forms of energy storage. Battery storage, which has really gotten the brunt of the investment and focus, but also thermal energy storage, which has significant benefits, especially as peak demand is driven by thermal loads. It makes sense to have thermal loads. But I would next slide or continue. So NREL actually did a study of a future grid, 2050 grid, based on 100% renewables, spanning different percentages of PV and wind, and with the assumption that everything is electrified. So the analysis shows that in all different distributions of PV versus wind, thermal, like disaggregated into thermal and non-thermal, so non-thermal being batteries or electric. Most of that mismatch between generation and demand can be dealt with thermal storage. I would also say that since the buildings is where demand growth is increasing, so it makes sense to have it on the building level. So yes, we will need grid storage, but if we want to minimize the distribution constraints, we need to focus on buildings. Next slide. So Ram already set this up. So next slide. So just wanted to show how thermal energy storage aligns to the blueprint. I'm not going to go through all of these, but I would just highlight prioritizing affordability. So thermal energy storage, even now, is cost competitive to batteries, in actually favorable in terms of economics. And there are lots of studies that show that thermal energy storage could be 1/6 or 1/10 the cost of batteries on the building level. Tesla Powerwall's like around $900 per kilowatt hour installed. Thermal energy storage, even with aggressive battery storage cost reductions and similar cost reductions on the thermal energy storage side, it could be a low cost option. Next slide. mapping it to increasing building and efficiency on site. So you can read it. I'm just going to highlight two areas, in terms of efficiency. Yes, we need to reduce the load with, advanced envelope retrofits. On top of that, thermal energy storage can actually increase system efficiencies. It can increase the performance of heat pumps, the performance, heat pump performance. It can harness, the favorable, ambient conditions, based on diurnal swings. And then secondly, in terms of, building life cycle emissions or critical materials, batteries, thermal energy storage is a scalable solution. The actual elements that are in thermal energy storage are not, critical materials such as batteries like lithium ion, lithium or cobalt or nickel. Next slide. So now we go into the Store-for-Build overview. This is the next slide. So we actually launched the Store-for-Build, which is a multi-lab consortium designed to advance or accelerate the development and demonstration of storage solutions. We launched this in December of 22, so it's actually not been more than 2 years. It was part of a lab call that we did in 2021. But it wasn't, funded and launched until December. Next slide. So it has several objectives. As I mentioned, we want to accelerate the development of thermal energy storage solutions, demonstrate them and field validate them in the lab as well as in the field. And importantly, facilitating synergistic collaborations with stakeholders. I'll get to that a little later. I would just, focus on the middle graphic on the right. We want to focus on system development that use optimized materials, optimized controls, optimized heat exchangers, for thermal energy storage solutions. Next slide. So in terms of the research areas, really driven by the end use and the systems development, using optimized materials specific to those applications, system-centric controls for those systems. And then we also have a modeling and analysis area, which is predominantly focused on a test sizing benefits and decision tool, which was actually the #1 critical need at our inaugural Store-for-Build annual meeting. And then lastly, on the standard test procedures for not just materials, but also performance standards on the system level is critical. Next slide. So we got 2 R&D or 2 steering councils, one on R&D, providing screening, technology screening, feedback on the technology pathway, as well as the market adoption steering council that helps with policies, market mechanisms, application end uses. And that feedback also relates back to the R&D, but also making sure that any systems that we develop have value, and looking at rate structures and whatnot. So both of these steering councils are driven by industry, by academia, supported by labs. Next slide. So I want you to get, this is just a taste of the consortium. We need a lot. We need a community to drive these solutions forward. So we want industry, utilities, building owners. We want everyone involved. So you can learn more on this QR code, or next slide, reach out to me directly. So with that, that's my talk.
Thanks so much, Sven. I really appreciate that overview. It's really exciting to see that a consortium come together. So I think, Kula, we're going to skip questions now, right? So we're breaking for another session. Our next session is around communication controls and interoperability. And here in Building 50 Auditorium, there's going to be a session on small buildings with Bruce Nordman. And over in Building 91, Jessica Granderson will be meeting around communications controls and interoperability in large buildings. So that session will start at 10 past the hour. And thank you so much for joining the next session.